Hey everyone, this is Morgan. We're going to be going over a pretty complicated homework today, which is called precipitation reactions. And there are a few things that you need to have handy. First, what you should do is get your copy of a solubility chart, because we're going to keep making references back to this all the time. You should have a formula writing grid. Okay, this is formula writing grid number 1 that I'm using. And as always, a periodic table is really helpful. Okay, so what I've written up here at the top of the page, just as a guide for me, is a classic double replacement reaction, AB plus CD. I know that A and C are the positive ions because they come first. I know that B and D are the negative ions because they come second, the way I write the formula. Now that means that C is going to hook up with B, positive, negative, and A is going to hook up with D, positive, negative. And then I'm going to determine which one of them is soluble and which one of them isn't. Okay, or maybe they're both soluble, or maybe they're both not soluble. All those things can happen. It's not unheard of. Okay, so first reaction there. AgNO3 and Na2CO3. We need to switch our partners. So what I'm going to do first is I'm going to locate on my formula writing grid sodium right here. Then I'm going to locate nitrate right there. NaNO3. NaNO3. Looks like I'm going to need a 2 in front to balance it. And now I want to put Ag with CO3. So I don't actually have Ag on this formula right once. So I could use Na plus K plus as my example. Okay? Na plus and all the way over here CO3 2 minus, that's Na2CO3. So what that means is I'm looking at Ag2 CO3. Okay? Balancing of going to need a 2 in front of the AgNO3. So what I do next is I just acknowledge that my reactants are always aqueous. They've got to be. Now, for my products, I'm going to go here to my rules. Compounds of group 1 elements are always soluble. Okay, that's great. Sodium's a group 1. It's soluble. That means it's going to be aqueous. Now for Ag2CO3, I've got to find something about carbonates. Carbonates are generally insoluble, except those of group 1 and ammonium, and well, I'm not dealing with either of that. I've got silver, so that means this is the solid. Okay, now anything that is aqueous can break apart in solution. So I'm going to have 2 Ag plus aqueous. I'm going to have 2 NO3 minus aqueous. I'm going to have 2 Na plus aqueous. And I'm going to have a CO3 2 minus aqueous. Now what's that going to give me? Well, over here on the other side, I'm going to have 2 Na plus aqueous. I'm going to have 2 NO3 minus aqueous. But the Ag2CO3 is a solid. So I write it together, not apart. Okay. Using some algebra skills, the 2 Na plus will cancel 2 Na plus, and the 2 nitrates will cancel the 2 nitrates. Now what does that leave me with? That leaves me with 2 Ag plus aqueous plus CO3 2 minus aqueous to give me Ag2 CO3 as a solid. And that's what I would call my precipitate. Okay, that last equation there is the net ionic equation. That's what I'm most interested in. Okay, now I'm swapping in number 2 nickel going to be hooking up with sulfide. So I'm looking over here at my table. I have nickel. I go across, ooh, hey, right there, sulfide. That's NiS. So I write NiS. And K is hooking up with Cl. So I go back over here, K and Cl, that's KCl. Now, if you know how to write your formulas well, you don't need to look at that grid. But I don't think you've had quite enough practice yet. So you probably need to do some more of that. Okay, now I'm over here. Sulfides. Sulfides are generally insoluble, except group 1 and group 2, and ammonium. Well, nickel is not group 1, it's not group 2, it's not ammonium. That means this is going to form a solid. Chloride, KCl. Well, that was that rule over here. Compounds of group 1 elements are soluble. So that's going to be an AQ. All right. So what does that leave me with here? I've got an Ni2 plus aqueous, and I've got 2Cl minus aqueous, and I've got 2K plus aqueous, and I've got an S2 minus aqueous. I can take them apart when they're aqueous. Now that gives me NiS solid plus, well, if I balance this correctly, I'm actually going to have a 2 in front of the KCl. So that's 2K plus aqueous and 2Cl minus aqueous. Okay. I look for cancellations. That's the 2K plus and the 2Cl minus. So what we're going to end up calling those ions are spectator ions. They cancel out. I can get rid of them. These are the ions that actually changed. So that's what I'm interested in. So in my net ionic, I have Ni2 plus aqueous plus S2 minus aqueous to give me NiS as a solid. Okay. There you go. That's the second one. And as you see, I keep going back and forth for all of these different reference papers as I'm working it through. Okay. Now, we're going to swap Na and the K. So Na is going to hook up with the OH. Here's my Na. Here's my OH. That is NaOH. Plus 1 and a minus 1 coming together. NaOH. And now K is hooking up with Cl. So there's K. There's a KCl. Got that. KCl. Now, both of these are group 1 metals. Okay, here. Compounds of group 1 elements are always soluble. That means these are both aqueous. And the correct answer to this question is no reaction. Okay? That's going to happen a few times. All right. Copper hooking up with the hydroxide. So I'm going to look here to see if I have copper. I do have copper 2 plus. I've got hydroxide over there. There it is. CuOH sub 2. Okay, so I can write that. CuOH sub 2. And I'm looking for sodium with sulfate. Sodium going across to sulfate, Na2SO4. There we go. Na to make everything balance out. Now, I'm back over here. Compounds of group 1 elements are soluble, so this gets labeled aqueous. Soluble means it's aqueous. Now, hydroxides. All right. So let me look through here, and I got to keep looking around for a minute. Hydroxides and oxides are generally insoluble, except group 1 and group 2. Well, I don't have group 1 or group 2. That's copper. That's transition metal. So that's a solid. So when I start to take everything apart here, Cu2 plus aqueous, I've got SO4, sulfate, 2 minus aqueous. Did I mention you need to know your polyatomic ions? 2 Na plus aqueous, 2 OH minus aqueous to give me. Okay, remember I recommended that you do this on a separate sheet because it just takes up a lot of space here. Sorry, it's so bunched up. That gives me Cu OH sub 2, which is the solid, and 2 Na plus aqueous, and a sulfate, SO4, 2 minus aqueous. Now those sulfates cancel, and those sodiums cancel. And with those canceled, I get Cu, 2 plus aqueous, plus 2 OH minus hydroxides, aqueous, to give me Cu OH sub 2 solid. And that's the precipitate. Okay? All right. So barium is hooking up with sulfate. So I got to look over here. I don't think barium is actually on this list. So I need something else that's a 2 plus like barium is. Calcium. Okay, they're in the same family. Okay, since, where we go? Calcium, barium, same family. They're going to have the same charges. So let me find calcium with sulfate. Got to go pretty far over. It's right there. CaSO4 will give me BaSO4. And this iron is a 2 plus. I know because it's hooked up to the sulfate. I got nitrate. So I don't have an iron 2 plus here. I got iron 3 plus. So I'm just going to use another 2 plus like calcium. Okay, calcium with the nitrate, CaNO3 parentheses sub 2. Now, I know right away this is soluble, okay, because nitrates are always soluble, okay? Aqueous. And the sulfate is generally soluble with some exceptions, and barium is one of those exceptions. So that's the solid. Okay, so what am I getting? I'm getting Ba2 plus aqueous. I'm getting 2 nitrates aqueous. And then I'm getting Fe2 plus aqueous, SO4 2 minus aqueous to give me BaSO4 solid, and I'm sorry, I wrote Ca there when I'm supposed to write iron. I am so sorry, people. Fe, oh, hold on. It's going to be Fe2 plus aqueous and 2 nitrates aqueous. Okay. The nitrates cancel. The irons cancel. So I have Ba2 plus aqueous. I have SO4 2 minus aqueous. And that is going to yield BaSO4 solid. Okay? All right. Those are the first 5. You kind of see how those are going. Okay? I'm going to encourage you now to actually go and do some more of these on your own. There'll be some other answer keys coming as we move along, and I might not give you quite as much detail in those next ones about how I'm thinking of, which one's soluble, which one's not soluble, etc., etc. All right? Okay. Everybody have a good day. This is Morgan signing off.